All right, so let's learn the half angle identities quick, because they're quick. So, quick, what were the things I just asked you to put somewhere else because we were going to use them later?
Double angle identities.
Yeah, the double angle identities for cosine specifically. I do not care about the sine one for this. So the double angle identities for the cosine are cosine of 2 theta is what?
Negative 2 sine squared theta plus 1.
So 1 minus 2 sine squared theta is one of them, right? And the other one is that cosine of 2 theta is what now? 2 cosine squared theta minus 1, right? Okay, now, yeah, and I'm probably lying a little bit. I'm sure these aren't actually called, I'm sure these aren't exactly what most books call the half angle identities, but these are what live in that space in my brain. These are the ones you're going to use. So what I'm going to do with these is I'm going to solve for sine squared, and I'm going to solve for cosine squared. Okay? So on this first one, how do I solve for sine squared? Good. Subtract 1. So you got cosine of 2 theta minus 1 is minus 2 sine squared theta. And then what? Multiply by negative 1 over 2. And so you're going to get what?
Negative 2 cosine 2 theta minus 1 equals sine squared theta.
Let's go with 1 minus cosine of 2 theta all over 2 is sine squared of theta. You guys with me on this? Okay, that's one of them. I want that to go in your head next to, oh my god, there's this sine squared and I can't get rid of it. Okay? This will let you turn sine squareds, right, into cosine of twice that angle. The twice that angle is not ideal, right? But in a lot of cases, it's better than having a sine squared kicking around. Guys with me on that? So this is a useful trick. This other thing, how do I solve here? So if this is cosine of 2 theta is 2 cosine squared theta minus 1.
I thought that was cosine theta minus 1, not 1 minus cosine.
I'm just dividing by negative 2.
Oh, you were dividing by a negative. Okay, sorry.
Yeah, the negative flip this under.
Yeah.
How about this guy? What do you do first?
Add 1.
Add 1 to both sides. Okay, so you got cosine of 2 theta plus 1 is 2 cosine squared theta. And then you'll
Divide by 2.
okay,
No, just 2.
multiply by 1 over dose. And that will get you to cosine squared of theta. Oops, is what?
Cosine 2 theta plus 1 all over 2.
Perfect. 1 plus cosine of 2 theta all over 2. This should go next.
Why do you write the 1 first?
I don't know, because I do. Because I wanted to make them look the same.
Oh.
And then I kind of screwed it up by writing that one as cosine squared equals, and this one is something equals sine squared. So these should go in your head next to, hey, it would be convenient to get rid of all the powers on these sines and cosines. Like, this trick lets you kind of break those out of there. There's a good reason that you might want to do that in calculus class, and these are super, super handy to have next to your, have in your brain next to that, like, oh crap, I'm panicking about sine squareds and cosine squareds. Cool?
What do you do with that?
It just depends on the
Yeah, so here's the issue. You will have a tool that lets you find the area under curves. Okay? This thing won't fit nicely into that tool, but this crap will. And so this lets you take a cosine squared, something that's not going to fit in the tool at all, and turn it into something that'll fit into the tool not very conveniently. So you're going to trade impossible for merely annoying. You guys cool with that? That's really like a super loose explanation, but yeah, that's the idea. Cool. So this will go in your brain as like, oh, holy crap, last resort. Let me turn this into something that looks really annoying, but might be doable. Cool. Other things?